Hi, I'm Elvic Cabais, and I'm going to be doing the project, which I have to explain two problems. And problem one is I need to find the number of steps that I need to take to climb this when I'm climbing stairs to lose the energy gained from eating a chocolate or candy bar. The candy bar has 250 calories, and the 250 calories we would have to convert it to joules. So it means I have to multiply 250 times 4,186, which gives me 1,046,500 joules. My mass is 92.533 kilograms, and the height of each step is 18 centimeters or 0.18 meters. We're looking for the height, so we're going to use the formula for internal energy, which is heat minus work. And to find work, we need to use the formula mgh. We're going to substitute mgh for W. So Q will be minus mgh. And then you switch over mgh. So it's going to be Q equals to mgh. And then we're going to try to isolate h by itself. So we're going to divide every side mg. And so our height is Q over mg. And now we're going to plug in the numbers. So our Q is 1,446,500 joules, and our mg is 92.53 and 9.8. So we divide those two, and we get 1,154.03 meters. And to calculate for the number of steps, we would have to divide 1,154.03 with 0.18 meters, which would result to 6,411 meters, or number of steps. And that's it. That's for the first one. Yeah, you can just cut it out. Problem two. This one, we're going to analyze the collision between the bullet and a wooden block. Okay, and the mass of the bullet is 8 grams, or 0.008 kilograms, and the velocity of the bullet is 441 meters per second. The mass of the wood is 1 kilogram, and the velocity of the wood is 0 meters per second. Okay, for the first part of the problem, we have to look for the final velocity. And to find for the final velocity, we're going to use the conservation of momentum. So for the initial momentum, we're going to use the mass of the bullet and the velocity of the bullet plus the mass of the wood and the velocity of the wood equals to mass of the bullet plus mass of the wood times the final velocity. And to find the final velocity, you would have to switch over mass of the bullet and the mass of the wood. So our final velocity, to find the final velocity, our formula would be mb times vb plus mw times vw over mb plus mw. And we plug in the numbers. So the first part is 0.008 times 441 plus 1 kilogram and 0 meters per second. This one cancels out because anything multiplied by 0 is 0, so cancel that out. And so we figured out, and for the top part, we get 3.528 over 1.008, and our final velocity would be 3.5 meters per second. And for B, it's asking if it's an elastic collision or elastic collision. It's an inelastic collision because they started moving together and didn't bounce off each other. And for C, we're looking for the heat. To find that, we would need the conservation of energy plus Q. So for the initial kinetic energy, we we use the 1/2 mb and v initial squared equals to 1/2 mv squared final squared plus q. And then we switch over the 1/2 mb velocity final squared, so we could leave the q by itself. And then we plug in the numbers after that. So it's gonna be 1/2 times 0.008 times 441 squared minus 1/2 1.008 times 3.5 equals q. So the first part we got 777.924 joules, and the second part we got 6.174 joules, and we subtract that, and our heat would be 771.75 joules. For D, we're looking for temperature, and we would need to use the formula to find heat. Q is equals to Cm, change in temperature. And since we're looking for temperature, we have to isolate it, so we would have to divide everything by Cm, so we could switch it to the other side. So to find T, we would have to divide Q by Cm. Now we plug in the numbers, and our Q is 771.75 joules over 128 times 0.008, which gives us 753.662 Celsius. And for the last part, we would have to find the acceleration. And to find the acceleration, we would need to find the forces. So we draw a free body diagram. The acceleration is going to the right. So our force is going up is the normal force, and going down is mg, which is the weight. It's negative. And on the opposite side, since there's friction, is the friction going to the left. So first we have to look for the forces going up and down, so in the y-axis. So sum of all forces in the y is equals to ma, which is just, it cancels out because it's not going, there's no acceleration up and down, so it's just 0. So that cancels out. So that means our forces is just going to be n minus mg, and we would need the m. So we just switch over the mg, so it's n is equals to mg. And now we move to the forces on the x-axis. So fx is equals to ma, and the only force we have on the x-axis is the negative friction. So a negative friction is equals to ma, and friction is mu times n. So we substitute that in, and then n equals to ma. And we would have, since we're looking for the acceleration, we have to move over the m. So we divide it by m, and then we switch it over. And since this one also has an m, we cancel that out. So we're left with negative mu g is equals to a. Then we just substitute the number in there. So negative 0.30 times 9.8. And that gives us, and our acceleration would be negative 2.94 meters per second squared. Thank you.